Thank you for joining this session. My name is Ken Tamagawa, Senior Manager of Solution Architecture in AWS Japan team.
Hi everyone, my name is Akio Okatayama, Solution Architect in Japan.
Hello, my name is Riyad Suzuki. I'm CTO at Cloud Park, a Japanese partner.
So we three are originator of Cloud Design Pattern. So today I'm going to talk about overview of Cloud Design Pattern, and Akio is going to demonstrate how CDP works. And first of all, I want to introduce my visit to Las Vegas. This is the second time, and great hotel and great room, also a great dinner, and we enjoyed our steak and enjoy gambling. Last night I lost $200 in 2 minutes, and so I named this Las Vegas pattern. So I don't want to talk about Las Vegas pattern today. So I want to talk about Cloud Design Pattern. Cloud Design Pattern is a general repeatable solution to a problem in the cloud architecting. So why we created a CDP? Because there are many AWS infrastructure services. There are more than 20 services, right? So you can do great thing by combining AWS services. For example, you can do this. Launch EC2 with EBS behind the EOB with your domain on Route 53 and your videos on CloudFront and back up to S3 and your database on RDS will merge AZ. So this is great, but for AWS beginners, it might be very confusing, right? So we also notice AWS architecting know-how on AWS has been learned over time. So as you actually use AWS, you will learn new findings and also know-how on AWS. So what is the best way to accumulate and communicate those cloud architecting know-how? Answer is Cloud Design Pattern. This can be a general way to describe a combination of AWS services and also the solution to the problem. This is might be similar with the logo tech book. These books include a lot of simple parts like doors and wings. So if you read these books, you know how to make simple parts. Then you can make a more complex model with combining simple parts. So simple parts is a Cloud Design Pattern. Let me explain example of a Cloud Design Pattern. So you can launch EC2 instance, and you can assign global IP address known as Elastic IP address, EIP. So thanks to the unique characteristic of EIP, you can attach or detach EIP anytime, and you can attach to the any instance instantly. So this can be used for the fault-tolerant architecture. For example, you have a EC2 instance and attach EIP. Then you have a standby EC2 instance. And if the server fails, you can detach EIP and then attach EIP to the new instance, right? We name this floating IP pattern, right? So how many people are using this already? Okay, so yeah, many people are using it already, I know. But so if we give a specific name to this pattern, it's easier to communicate. So also another example, this one, okay. So actually I was talking about CDP in AWS user group, and a power outlet is very far. So I managed to stretch my power AC adapter. So my friend took this picture. So I named this floating AC adapter. So this is anti-pattern. So you shouldn't do this because AC adapter is a single point of failure. But ThinkPad has some battery. So well, yeah. Anyway, so going back to the floating IP pattern, this is already used by NASA. So NASA used this for the automatic failover across availability zone. So next example is a weighted transition pattern. So you might want to migrate one system to another from on-premise to AWS Cloud or from one region to another region. So Route 53 has a weighted round-robin feature known as DNS load balancing. So you can use this for the smooth transition. So this weighted round-robin allows you to specify weights to the DNS record that specify how many traffic want to be routed to the various endpoints. So you can first assign very small portion to the new system for the testing purpose. Then you can gradually shift more traffic to new system. So finally, you can finish a smooth transition. This is a weighted transition pattern. So another pattern is a job observer pattern. Decoupling very important. Amazon has our Amazon Simple Queuing Service, SQS. So for example, one group of EC2 instances accept images and put task into queue in the Amazon SQS. Then another group of instances look at the queue, and then if they found the tasks, get task, and then work on the resizing images. A queue allows you to decouple system. But here's the question: how you can do the assign the best amount of servers to the work? So you can use the Amazon CloudWatch. This allows you to monitor the number of tasks in the queue. Then you can put some criteria. So Amazon CloudWatch can signal to the auto scaling and then create more server for the group of the EC2 instance to working on the resizing images. So this is the job observer pattern. So I already told 3 patterns. Each pattern follows the CDP template. This includes the problem and solution. So we try to avoid the AWS terminology in solution because for AWS beginners, it's easier to understand. And the implementation section, we use AWS terminology. So it includes all of the details of the CDP. Also, there are pros and cons in each CDP. So I try to explain trade-off in the specific CDP. So we have a lot of CDP already. Some CDP is very simple, and some CDP are very complex and advanced. As of today, we have 48 patterns here. So we categorize into 9 categories: basic, availability, scaling, static contents, data uploading, relational database, batch processing, maintenance, network. So if you look at the basic, there are many basic patterns like snapshot, stamp, scale up, on-demand disk. You can imagine what kind of things CDP doing. So actually, we published a book about CDP in Japan. Surprisingly, this became a bestseller. Already 7,000 reprinted. So now we are working on English translation. Also, we have a wiki. Unfortunately, this is also in Japanese. But
sorry.
But so you can use Google translation to look at what kind of content here. So I'm sorry. But so I hope you understand what is CDP. But so as we develop CDP, we noticed even we have CDP, it's kind of difficult to find which CDP should be used in specific scenario. So we developed the implementation scenario. This is kind of a realistic use case, kind of used to point out a problem you might face in the realistic situation. For example, e-commerce scenario. In the e-commerce site, availability or fault tolerance is most important thing, right? So if the server of the e-commerce site fails, you cannot earn money. So availability is most important. Okay, so today I want to talk about 3 implementation scenarios. First one is a content distribution scenario. In this scenario, assuming you start your personal blog, which uploading photos of crowds. So this is a personal blog. So you want to minimize your cost to the absolute minimum level. So, but also cost efficiency and high performance is very important quality attribute. Environments. So we pick this package for this site. Especially we chose a movable type because movable type has something called static publishing, where rather creating dynamic page each time request is made to the blog. HTTP server can handle with the HTML file which was created by the movable type. So you can decrease the server resources by using a movable type. Initial design looks like this. So you put everything into one EC2 server and assign EIP. And this has like a unique domain name, www.clouddesignpattern.org. And root 53 can reserve the domain name. But the problem happens. So if you look at the comments, visitors are leaving. So you notice many visitors want to see videos as well as pictures. But you are concerned about the size of videos. If you put like a video, it might be the hundreds of megabytes, sometimes gigabytes, right? So download traffic can be tie up, can eat out the server resources. So what you can do? You can do the web storage pattern. Web storage pattern uses Amazon S3 as a static content provider. So this is very simple. You just put video into S3, and then S3 can create a URL for publishing. So you just put URL into your blog post. So user can access to the blog post and then click the download link, and S3 can directly provide the content to the user. Very simple. So now you can smooth out the traffic of video, but another problem happens. So you have like more visitors, and web server cannot handle with the traffic. So what you can do? You can do the direct hosting. Direct hosting pattern uses Amazon S3 as a HTTP server. Amazon S3 has a unique feature, website hosting feature. So you're going to put all of the static file into the Amazon S3. Then, Amazon S3 can work as a HTTP server. So only one thing left to the EC2 web server, gonna create a dynamic file each time, blog post is posted. So now almost like works, provided by the Amazon S3. You don't need to care about, provisioning EC2 server. So this decreases the cost of the, whole system too. So another problem happens. Crowd funds in Japan, increasing, and also the demonstration.
Oh,
so
we're gonna
Akio wants to demonstrate direct hosting pattern.
So this demonstration shows how to apply direct hosting pattern to host static content on S3. Okay, let's get started. Okay, the first things we do is create a new S3 bucket to put static content, and adding a bucket name So the important thing is that you have to name S3 bucket same as domain name of on your website. It's an important rule when we use S3 as a website. So put some configuration to the bucket. Enables S3 website hosting feature to use S3 bucket as a website. So move to website tab and check enable button and type index HTML to the text box. Then apply these settings. Also change access permission. We can't access S3 bucket without authentication by default. So apply public bucket policy to allow everyone access to the bucket. Okay. Save this configuration. So after set up this bucket, upload website content to the bucket. So in the demonstration, AWS Management Console is used to upload static content from local to S3, but in the scenario, all of contents are uploaded from EC2 to S3 through S3FS. So we can access the S3 website with a domain name that is provided by website hosting feature. We can get this URL in the website tab, like this URL, long URL. So we try to access to the site, but some part of the site are broken. This is because static publishing of movable type generate dynamic content with obsolete URLs. So the referred site of top page are broken. So we have to correct domain. We have to put correct domain to DNS to fix it. Use root 53 to apply on domain name to S3 bucket. So open root 53 console and select hosted domain. So create a new DNS record. Then type host name www and select CNAME type. Okay, and put S3 provided domain name. Okay. So once we put this configuration to root 53, we can access S3 website with own domain name. Type domain name www Cloud Design Pattern. We can get this page. Great. It is easy for us to host static contents directly by Amazon S3.
Okay, now in this scenario, already your site smooths out the traffic by using the direct hosting pattern. So you have more visitor to the blog site in Japan, and crowd funds in the US also starting visiting to the site, and surprisingly, media site in Japan in the US introduced this site. So this is a problem. Because you are excited to increase the traffic, but you are hosting videos, and those large size file will be transferred to across the ocean to the users. It takes a lot of time, so you don't want to let the reputation of the site suffer from the not good user experiences. So you can use a cache distribution pattern. This is using CloudFront. CloudFront is cache services that are having a cache in the server located throughout the world. There are more than 35 edge locations right now. So CloudFront can serve a cache file from the location which is closest to the user. So in this scenario, we created two distributions of CloudFront. Distribution can specify the origin server or origin bucket of the S3. So for the blog content, we created one distribution, www.clouddesignpattern.org. And another contents, videos and images, and we created data.clouddesignpattern.org. And EC2 server just for the making static site when the owner gonna upload a new blog post. So throughout the scenario, you understand we face some problems and then apply cloud design pattern to solve the problems. So next scenario is e-commerce site. So you have a personal blog, and that blog became very popular, and now you come up with the idea, maybe I can sell the photos of cloud or cloud-related product in e-commerce site. But an e-commerce site, you gotta have the very high availability. In this scenario, we have this environment. So we use EC Cube. This is an open source e-commerce site made in Japan. We put everything into one EC2 instance because we are not sure how successful this e-commerce site. So AWS allows to scale up as needed. If you have more traffic, you can scale up the server. You can start from small. So, but you have a problem right now. You got an email from one user. He wanted to buy a cloud picture, but he cannot buy in the e-commerce site. So you look at the website and you find out server is failing. So what you can do? You don't know the exact detail why server is failing, but you need to recover ASAP. So you can apply a server swapping pattern here. Server swapping pattern launch new EC2 instance from Amazon machine image previously taken. And then, this new EC2 instance doesn't have latest information. So you're gonna steal the EBS volume from the original server. Then, put the EBS volume to the new server. Then adjust the setting in the new EC2 instance to reference the latest information. This is a server swapping pattern. So this is, swapping the only server part. So this is, server swapping. Now, you recover the server with minimum downtime. This is great. But, your pretty boss is saying, don't do that again. So you want to add some, redundancy to the web layer. So you're gonna look at the, dump file and also log file, and then you will find out what is the, root cause. So your application has bug. So you just want to, redundant configuration in the web layer. So in this case, you can apply a multi-server pattern. So simply, you have a redundant, resources under ELB, and then ELB gonna distribute the traffic. So this is a multi-server pattern. But before applying this pattern, you need to split web server layer and database layer. So in this case, you can launch EC2 instance and install MySQL here, but you decided to use Amazon Relational Database Service, RDS. Because RDS is pretty easy to use. You just click and you can choose an engine, MySQL, Oracle, and SQL Server, or you can specify a database version. And also you can specify the data volume. So you can quickly launch the RDS. Also, for the load balancing part, you can use ELB. ELB also pretty easy to use. You just need to specify a port. Adding to the standard port 80, you can add SSL for e-commerce site. And you just put two EC2 server under the ELB. So if you need 3 servers in system, you just put 4 servers, kind of like an N+1 servers rule of thumb. So now we have redundancy in the web layer. So how you can check this? You can intentionally terminate server, then you can check how system working correctly. So Akio is gonna demonstrate that part.
So, okay. This demonstration shows how redundant this system is after multi-server patterns are applied. Okay. Okay. Two EC2 instances have been launched, and elastic load balancing has been launched. So two instances are running, and both of them are under the ELB, like this chart. So these EC2 instances are running HTTP servers and running PHP applications. Let's access the web application. So type application URL, access to the application. So it's a clock application. Looks good, isn't it? Okay. So this application is generated by PHP application. So this web page is refreshed every time. This means this browser doesn't use local cache. Multi-server pattern enables us to avoid system failure. The system as a whole will to continue to operate without problems, even if there is a problem in one of the web servers. So let's simulate this system whole can work even if one web server fails by any reason. Select EC2 instance, then select terminate menu. Then terminate this instance. Okay. So after a while, this instance will be terminated, but we should be able to access this web application without problem because another instance is still running. Okay, try to access the application again. Reload this page. Okay, this application still works well. So we can apply the multi-server pattern to the web server part to increase the fault tolerance of the system as a whole.
Okay, now you have redundancy in the web layer right now. But the system as a whole, redundancy configuration in web layer alone is not enough. So now database layer is kind of a single point of failure. So you want to add redundancy in database layer. In this case, this is pretty easy to implement because you are using RDS. So you just turn on the setting of the merge AZ deployment from no to yes. So then RDS is gonna launch standby database server in different data center location and do the synchronization between master and standby database. So even the master database fails, RDS is gonna do some like automatic failover to the standby, and standby will be promoted to the master. Now you have this, system configuration. So you have redundancy in database layer and also in the web layer. But if you look at the web layer, multiple server is there in web layer, but it's in the same, database location. So if you want to be ready for the, less, likely occasion, such as, large scale failure of the data center, such as earthquake or power outage or hurricane. So you want to be ready for that. So you're gonna add the merge data center pattern. So merge data center pattern, you just need to relocate servers in different data center location, different availability zone. So before you have AWS, it's very difficult and also expensive to have the servers in the different data center location. But AWS offers availability zone. In each region has more than 2 availability zones. So easy to implement this pattern. Also, ELB can distribute traffic into the EC2 servers, which are located in the different availability zone. So through the scenario, we add more redundancy in the system. So we use server swapping, for the quick recovery, and we add a mulch server for the redundancy in web layer, and DB replication for the database layer, and mulch data center layer for the system redundancy. Okay, so last scenario, campaign size scenario. So now you have a personal blog, and also e-commerce site, and you come up another idea. Maybe I can have a campaign site to drive more sales on e-commerce site. So this is a campaign site scenario. You need to take care the sudden traffic caused by the campaign. So in this environment, we use these packages and software. Especially, we chose WordPress as a content management system because WordPress is kind of like a stateless design, so it's easy to scale out. But in the initial design, so even I wanted to have a campaign, but I thought it's difficult to design the scale out things first. So I wanted to have like a very small website, and if I have like a higher traffic, I can handle with the traffic by scale out pattern. It's easy, right? So just changing EC2 instance type from small to large with more CPU powers and with more memories. But so I decided to advertise product on television. So in this case, this is very exciting, but it's very scary. You cannot expect how much traffic coming to your site. You think it might be happening, like huge traffic is coming, and that is not handled by the scale up pattern. In this case, you need to do scale out, parallel processing. But the initial design, you didn't think about scale out design. So your site is not designed for the scale out. What you can do? So you can apply clone server pattern. So clone server, you just cloning the server from master server, original server. So before applying this pattern, you need to prepare for the Amazon machine image for cloning. What you can do, you just simply take a machine image from original master server, then launch the temporary server. In the temporary server, you're gonna set some adjustment. For example, your clone server should reference to the data in master server. Also, you can copy those contents into clone server on the periodic basis. So then you can create like an Amazon machine image for clone server. So all set. You just need to add a clone server from AMI as needed. So then you can apply scale out pattern here too. So auto scaling enable you to add more servers, as necessary. So, or decrease the server. Because you apply clone server, already you have a AMI, so it's easy to apply a scale out pattern here. Also, it's important to have a stateless design. WordPress is a kind of stateless design, so in this case, it's easier to implement a scale out. So Akio is gonna demonstrate the scale out.
Okay, this demonstration shows how scale out pattern works. Auto-scaling feature enables us to apply scale up pattern to web server part. Okay. So there are two EC2 instances, and they are running under ELB and enable the auto-scaling feature. If number of HTTP requests will increase, auto-scaling will detect it and add a new EC2 instance with specified AMI. So let's put stress to these web servers. This terminal is connected to EC2 instance to run Apache Bench. So Apache Bench is a load testing tool that can send a lot of HTTP requests to web servers. Using AB command and -n option means total number of HTTP requests to perform, and -c option means number of multiple requests to make. Then type destination of web server and start this benchmark. So now Apache Bench is sending a lot of requests to these web servers. Just a few minutes. So autoscaling detect increasing number of HTTP requests, then autoscaling add a new EC2 instance to the group of web server. Reload this console, then we can find a new EC2 instance is added by autoscaling. Okay, so let's put more stress to these web servers. Increasing number of multiple requests from 100 to 300. And also increase total number of HTTP requests. Then restart Apache Bench. Wait a few minutes, we can find some new EC2 instances added by autoscaling. Good. So actually, for demonstration purpose, I cut some scene to shorten the time of whole scenario. So it normally takes several minutes to detect traffic and increase instances by autoscaling. So with these patterns, we can scale out the system as needed.
So by applying the scale-out pattern, so your site managed to survive even when your product on television. So, but while up to this point, your priority is on handling heavy traffic, for the advertisement. But you also notice you need to update the contents, right? So you need to update the content, but also need to take care of sudden traffic. What you can do? You can do the NFS sharing pattern. So this pattern uses NFS on EC2, network file system. So you can create directory, and then you can put the contents of a master server into the NFS directory. Then, clone server mount that NFS for the referring to the contents. In this way, synchronization of the contents between master server, clone server can be done. So this is an easy pattern. But also, you have another problem. So NFS part can be like a bottleneck easily because clone servers and master server are referred to NFS. So kind of like NFS part is can be very easily bottlenecked, especially if you have like more traffic. What you can do? So you can apply NFS replica pattern. This is kind of the combination of clone server pattern and NFS sharing pattern. So you can split contents into two categories. So one needs more high real-time synchronization. Another one needs more performance rather than synchronization. So then for the contents need a real-time synchronization, you can have clone server reference NFS directory. And for the contents need more performance, you can clone server to copy the contents in NFS to the local disk, and then reply that local contents to the request. So this is combination, but this is kind of like a easy way to handle with sudden traffic, but also the real-time update needs. So far, we modify the architecture by applying cloud design pattern. But you notice there are a lot of static contents here. So maybe I can apply a web storage pattern here. So now you have like a URL rewriting pattern. This is a kind of advanced model of web storage pattern. Basically, you're going to put all of the static contents of EC2 servers to S3. But so dynamically, you're going to convert URL of static contents in EC2 server to S3. Especially, Apache has a helpful module called mod ext filter. So this allows you to dynamically convert HTML link from EC2 to S3. So far, we introduced 3 implementation scenarios and some part of CDP. Unfortunately, you don't have a lot of time. So I cannot explain all of the 48 patterns. But you can look at the CDP wiki through Google Translation. So, and if you are interested in CDP, please look at the wiki. So as a closing remark, I want to explain the AWS pace of innovation. So Andy explained the pace of innovation in the keynote, and I like really this concept. And so actually I found like one blog which is talking about AWS is always excited to have new releases. So I named this very excited pattern. So I want to apply this very excited pattern at the end of this presentation. So as a closing remark, I'm really excited to introduce English version of CDP. So we finished translating Japanese CDP into English. So you can access to n.clouddesignpattern.org. And this website includes all of the detail of 48 CDP. So I really appreciate if you can, have a feedback to this presentation. Thank you very much.
Thank you.